You've seen the pictures, maybe you've even seen it yourself. A full moon, hanging in the sky, glowing a deep, menacing copper or a haunting rusty red. It's dramatic. It's eerie. And for thousands of years, humans looked up at this and saw a sign. An omen. For ancient civilizations, it was a warning of war, famine, or the end of the world. The Inca believed a great jaguar was attacking the moon, its blood spilling across the sky. The Mesopotamians saw it as a direct threat to their king. But if you strip away all the mythology and the fear, what's left? Not a monster, not an apocalypse, but something totally natural, perfectly predictable, and so scientifically beautiful it will change how you see the sky. We call it a blood moon, which is really just a catchy nickname for a total lunar eclipse. The secret to its crimson glow isn't some celestial mystery, but a beautiful trick of light, put on by our own planet. The moon isn't the one changing, Earth is putting on the show. Today, we're breaking down what's actually going on when the moon turns blood red. We'll get into the celestial mechanics, the atmospheric magic that paints the moon, and show you how you can see it for yourself. This isn't just a science lesson, it's a new way of looking at our home in the cosmos. When the moon turns the color of blood, ancient cultures thought the world was ending. But the real reason is one of the most beautiful tricks of physics happening right over our heads. You're told it's Earth's shadow, but that's not the whole story. What if you're actually seeing the light of all the sunrises and sunsets on Earth, all at once, projected onto the moon? Deconstructing the shadow. Alright, let's get the basics out of the way. To understand the color, you first have to understand the shadow. The moon, as you know, doesn't make its own light. It's a giant, dusty mirror, reflecting the sun's brilliant light back at us. That's what gives us that familiar, silvery white full moon. A total lunar eclipse happens when the cosmos lines up perfectly: sun, Earth, and then moon. In this straight line, Earth gets right in the way of the sunlight headed for the moon. Our entire planet casts a massive shadow that stretches for hundreds of thousands of miles into space. If you were an astronaut standing on the moon during this, you'd see something incredible: a solar eclipse, with the Earth as the star. You'd see our planet as a giant black disk, but it would be rimmed with a fiery halo of light as it blocked out the sun. This would plunge the lunar landscape into a deep, twilight darkness. The darkest, central part of Earth's shadow is called the umbra. So, the logical question is, if Earth is completely blocking the sun, why doesn't the moon just disappear? Why isn't it pitch black? Why does it glow red? The answer isn't out in space. It's right here, in the thin, fragile layer of gas wrapped around our planet, the atmosphere. The core revelation, the physics of red. Even when the solid part of Earth blocks the sun's direct light, our atmosphere acts like a lens. Sunlight still streams past the edges of our planet, and when it does, it has to pass through that thin shell of air. And this is where the magic happens. Sunlight, which looks white to us, is really a whole spectrum of colors. As this light enters Earth's atmosphere, it hits air molecules and dust. This makes the light scatter, but not all colors scatter the same way. The process is called Rayleigh scattering. Shorter wavelengths of light, the blues and violets, get bounced around and flung out in every direction. This is exactly why our sky is blue during the day. You're seeing blue light scattered from the sun. But the longer wavelengths, the reds and oranges, are a bit tougher. They push through the atmosphere more easily, continuing on their path with less fuss. So, as sunlight grazes the edge of our planet, the blue light is scattered away, while the red light pushes through. But it doesn't just keep going in a straight line. The atmosphere also bends, or refracts, this leftover reddish light inward, toward the center of Earth's shadow. Imagine it this way: you're on the moon, looking at Earth during a total lunar eclipse. You'd see a black disk where our planet is, but it would be surrounded by a brilliant, fiery red ring. That ring is the combined light from every single sunrise and sunset happening along the edge of Earth at that exact moment. So, when the moon passes into Earth's shadow, it isn't thrown into darkness. It's bathed in the faint, reddish glow of our planet's sunrises and sunsets. The blood moon isn't bloody at all. It's the ghostly echo of our planet's daylight, cast upon our celestial neighbor. You are literally seeing the glow of Earth's horizon projected onto the moon. Why every blood moon is different? This is where it gets even more interesting. If the physics is the same every time, why does each lunar eclipse look a little different? Some are a bright, fiery orange. Others are a deep, coppery red. And sometimes, the moon can get so dark it almost vanishes. The answer, once again, is our atmosphere. The color and brightness of a blood moon are basically a weather report for Earth's terminator, the line between day and night. If the atmosphere along that edge of the planet is relatively clear, more light gets through. This gives you a brighter, more vibrant eclipse, with coppery and orange colors. But, if that band of atmosphere is thick with clouds or full of dust and aerosols, it blocks more light. That makes the eclipse appear much darker, a deep, muddy red or even brown. A major volcanic eruption, for example, can pump tons of ash into the stratosphere. This creates a much denser filter, leading to unusually dark eclipses. After the 1991 eruption of Mount Pinatubo, the lunar eclipse on December 9, 1992 was so dark that many observers rated it a 0 on the Danjon scale, meaning the moon was almost invisible. Astronomers use a 5-point scale to classify the brightness of an eclipse, called the Danjon scale. It ranges from L equals 0 for a nearly invisible moon to L equals 4 for a bright, orange copper moon. This scale isn't just for a pretty description, it's a subjective, real-time way for observers to measure the general transparency of Earth's atmosphere. By looking at the moon, we're actually studying our own planet. A modern tool from an ancient omen for most of history, a blood moon was terrifying. Today, it's become a useful scientific opportunity. Beyond just being beautiful, astronomers and climate scientists can use the color and brightness of an eclipsed moon to get a rough idea of what's happening in our atmosphere. By analyzing the light that has passed through our air, they can gather clues about aerosols, tiny particles of dust, smoke, and pollution. It's a recurring natural experiment that gives a qualitative snapshot of global atmospheric conditions, helping to track things like the spread of volcanic ash. There's another reason this matters for the future. As we prepare to go back to the moon, understanding lunar eclipses is a safety concern. During an eclipse, with direct sunlight cut off, the lunar surface temperature drops dramatically. The change can be extreme, creating a thermal shock that's a huge challenge for rovers, landers, and future habitats. Studying how the moon cools during these events helps engineers design equipment that can survive one of the harshest environmental changes the moon offers. Witness the spectacle yourself. This isn't just something you have to read about. You can see it for yourself. The next total lunar eclipse will happen on the night of March 13th to 14th, 2025. It will be visible across North and South America, as well as Western Europe and Western Africa. During this event, the moon will be fully inside Earth's umbral shadow, glowing with that signature reddish color. Here's how you can get ready to see it. First, mark your calendar, March 13th to 14th, 2025. As the date gets closer, check the exact timing for your specific location. Second, find a good spot. The great thing about a lunar eclipse is you don't need to be in a super dark, remote area. You can watch it from your own backyard. Just try to find a place with a clear view of the sky. Third, you don't need any special equipment. Unlike a solar eclipse, a lunar eclipse is perfectly safe to view with your naked eyes. Binoculars or a small telescope will make the view even better, letting you see the colors more vividly, but they aren't required to experience the awe of the event. Watch as the eclipse progresses. You'll see Earth's shadow start to take a bite out of the moon. As it moves deeper into the shadow, the colors will start to show, shifting from gray to orange, and finally, during totality, to that deep, beautiful red. The blood moon is a cosmic paradox. It's an event that was once seen as a symbol of destruction, but it comes from the most elegant and orderly principles of physics. It's a spectacle of darkness that is literally created by light. It is Earth's shadow, yes, but it's an illuminated shadow. It's the filtered and redirected light of our planet's sunrises and sunsets, all gathered together and painted across the face of the moon. The next time you see the moon turn red, don't see an omen. See a reflection of our world. See the glow of our planet's horizons, reminding you of the delicate atmosphere that makes life possible and the beautiful physics that holds our universe together. You're not just looking at the moon, you're looking at a portrait of the Earth, painted in light. If this video changed how you'll see the next lunar eclipse, hit that subscribe button and join our community. We believe understanding the cosmos is one of the most rewarding adventures there is. What's the most incredible thing you've ever seen in the night sky? Share your experience in the comments below. We'd love to hear your story. Thanks for watching, and never stop looking up.